Now this is amazing. This is a magical natural masterpiece that I'm looking at here. What the heck am I looking at? Well, hopefully you know what this is. It's the Grand Canyon. The Grand Canyon is one of Earth's most natural, amazing places. I'm sure it's hard to come up with a name for it. And like, hey, it's a canyon, it's grand. Any ideas? How about the Grand Canyon? You're good. I'm sure that's how that went down. Now, your mind, when you see it, you're just blown away. It's stunning. And you're like, what the heck am I looking at? This is amazing. And how the heck did this come to be? Geologists are amazing. The rock detectives, they've come up with an understanding of a lot of amazing things on Earth. Now, they got a cool acronym, a mnemonic device, something that helps you remember. And that the acronym is DUDE. DUDE stands for deposition, uplift, downcutting, and erosion. So somebody's like, dude, how did the Grand Canyon form? You're like, exactly, it was DUDE. Okay, the canyon wasn't formed until they think around 5 to 6 million years ago. But we got to get to how these rocks became what they were before we start talking about how the canyon was formed. All right, so what do we got? Almost 2 billion years ago, we had mountains in this region. Okay, Earth looked different. Think about Pangea, continents were different. Erosion was actually able to erode all the mountains away. So the Vishnu Mountains just became flat again. But that rock was there. That rock is actually the base of the Grand Canyon, about 1.84 billion years ago. The oldest rocks of the Grand Canyon are at the bottom, right? Think about rocks piling up, oldest at the bottom, young at the top. Those old rocks at the very base of the Grand Canyon are from those ancient mountains. There was a period of unconformity. The geologists were like, hey, what happened to the rock here? It's gone. For whatever reason, there was some time period where the rocks that were there are no longer there. Probably got eroded away. And then 1.25 billion years ago, it picks up. We start seeing more rocks. How did these layers form? Think about how this part of Earth was changing throughout millions of years. It wasn't always this type of climate and environment. Okay, sometimes you had tropical environments. Sometimes you had like inland seas around here. You had lakes, dry deserts and whatnot throughout time periods. And so you're going to have different types of sediment based on what this region was like at that time. Okay, you think about if there was an ocean, you have things settle down in the ocean, right? Old marine life. And so the bottom of the ocean starts to fill up with some sediment. When the ocean goes away, now you've got all this sediment there, and that can harden the rock. Okay, maybe large sand dunes that can turn into sandstone. Sand actually can cement into rock. Maybe you have a very tropical, marshy kind of environment at that time that can create mudstone. It gives you an idea of how rock can be formed from an environment, whatever you have at that time. Pretty cool. We got a whole layered cake of rock. And so that's happening over millions of years. So that's the deposition. Now the U, uplift, comes from this whole region. The Colorado Plateau was uplifted due to some tectonic forces. There are still some uncertainties. Scientists are like, we're not totally sure why this uplift happened. These layers just were raised upwards, so you still had the layers in place. So now you got the layers up. However, they're still not exposed until you have the next D, which is downcutting. Okay, the Colorado River was key to the Grand Canyon. Of course, the river started cutting down into the ground and started exposing these layers. How did the river cut down that well? Well, the Colorado River has always been a powerful river. Okay, they believe it started around 5 to 6 million years ago. That's when the Colorado River became a thing. That's when the Grand Canyon started forming. It's not just a meandering, slow Mississippi River type river. This thing is cruising down from the Colorado Rockies, gathering a lot of sediment, a lot of rocks and all kinds of stuff in it. It's flash floods too. That's going to start really eroding away at the rock. And then even into the Grand Canyon, you have it drops down 2,000 feet from the east side to the west side. Now, so that's going down at a good pace with a lot of sediment in it, and this is going on for millions of years. The last letter of dude is E, and that's erosion. Okay. Now, there's erosion from the river cutting through, but also eroding sideways. This is a super wide canyon, up to 18 miles wide. How the heck did it get that wide? You had a lot of rain and wind also knocking down on the sides, and a big thing was frost wedging. I'm up here at the north rim, over 8,000 feet in elevation. It gets cold. You get a lot of ice and snow in the wintertime. daytime, that snow will start melting, turn to liquid water. That liquid water can go out into the cracks of the rocks. Nighttime, that freezes. It's interesting that when water freezes, it expands. If it does that in cracks, rock cracks, it's going to expand the rock a little bit, and that rock can start falling apart. You start losing some land there at the edges of the canyon, starts widening over millions of years, right? They're like, okay, let's look at some of the rocks in this whole area. We can date them. They got some great ways to figure out how old rocks are. And then they were like, well, is there any evidence that there was a river? We know how old the rocks are. There's no river sediments around here. River wasn't a thing here. And so it wasn't until about 6 million years, or rocks in some of the land around here, they're 6 million years old, that they saw evidence of a river coming through, and they're like, that's the Colorado River. That's when it was born, around then. But how do scientists actually know how old these rocks are? They could just look at them closely in a microscope and be like, yeah, it feels about 200 million years. Not exactly. They have something called radiometric dating. Now, what the heck is this stuff? Well, it's amazing what they figured out. If you think about different elements, all these basic types of matter out there, from hydrogen to carbon to neon to gold, right? They have atoms in them, and there's a certain amount of protons in that atom that makes it that element. Okay, so carbon has 6 protons, right? Hydrogen has 1 proton. There are actually different variations of these atoms in these elements. Those different variations are called isotopes, and it means that they have the same amount of protons, but different amounts of neutrons. Okay, it doesn't have to be a match. So carbon-12 is one that has 6 protons, 6 neutrons, but carbon-14 has 6 protons and 8 neutrons. Some of these isotopes just stay as they are. Those are stable, but there are some that are unstable. Okay, for example, carbon-14, 6 protons, 8 neutrons, it doesn't want to stay as carbon-14. It actually will decay into a different element, in this case, nitrogen-14. Pretty incredible. They figured out the amount of time it actually takes for these isotopes to decay. It slowly decays, and it's an exponential decay, meaning it starts off decaying quickly, but over time it's decaying, but not as quickly. They've actually figured out the amount of all these different half-lives, and the half-life is the amount of time it takes to change half of what it is into half of what it's going to become. Its parent isotope to its daughter isotope, it's what it becomes. For example, carbon-14 takes 5,730 years for it to decay into half of carbon-14 and half nitrogen-14. Okay, so after that amount of time, it's 50-50. The next half-life, now we lose half of that 50-50 amount. Now we're at 25% carbon, 75% nitrogen, right? And then the next half-life, next 5,730 years, it loses another half, and so now we're at 12.5%, and then 87.5% of the original. And so they can compare isotopes of an element. The stable isotope, for example, carbon-12, they look at how much of that is in there, because that didn't change. But then they can say, okay, but there's just this amount of carbon-14, it's a pretty small amount, so we can compare the amount of carbon-14 that has decayed into nitrogen-14 compared to the original amount of carbon from carbon-12, and we can see about how long this thing has been around. So they don't use carbon-14 for rocks because the decay life is so fast, right? Is not a lot of time geologically speaking. They can use that carbon-14 for plant life, animals, a lot of fossils, right? For rocks, they often use like uranium-238 decays into lead-206, and the half-life of that is 4.5 billion years. There's also uranium-235, that decays into lead-207. Stuff scientists have figured out, it's pretty mind-blowing, and it works pretty well. Awesome. Let's talk weather. Now, weather of the Grand Canyon is definitely pretty interesting. A big part of that is because, well, look at this elevation difference. It really depends on where you're at the canyon as to what kind of climate you have. Up at the top of the rim, relatively cool summers, pretty chilly winters. Okay, at the top of the south rim, you're about 7,000 feet in elevation. Top of the north rim, you're about 8,200 feet. But down at the bottom of the canyon, you're like 2,000 feet. That's a big elevation difference, isn't it? And so with that elevation change, you can have quite a bit of temperature change. On average, is around 20, 25 degrees cooler down at the bottom of the Grand Canyon than the top. So yeah. So in the summertime, you could be up top like, oh, this is nice, 80 degrees. You hike down to the bottom like, what? This is 105 degrees down here. Jeez. So yeah, going down there in the summer is not the ideal time to go. But the wettest time of the year is actually the monsoon season. You got to keep in mind if you're heading late summer, because the desert Southwest warms up quite a bit. And you think about warm air rises. Now, with that forming, it's going to change the wind direction in general. And so what that does actually brings winds up from the south. And to the south of Arizona, you've got a lot of water down there. The Pacific Ocean, Eastern Pacific, and there's the Gulf of Mexico in the area. So winds will actually come from these whole moist areas from the Gulf of Mexico and Eastern Pacific and bring this moisture up into the desert Southwest. You've got moisture and midday, a lot of sun, and that warmth will actually start to rise. Some uplift there is going to cause some clouds and precipitation, storms, heavy rains, a lot of lightning. Okay, you do not want to be in these canyons if there's a chance of flash flood. That's a bad situation, because what looks like it's a nice chill river could turn into a major flash flood. It turns out the Grand Canyon is actually the national park that gets the most amount of lightning. Also, something to think about is that there are a bunch of microclimates within the canyon, not just based on elevation, but also based on how the canyon is affecting. So as the sun's hitting different canyon walls and different crevices and areas where they don't get very much sun, there's all these other little factors too. The Grand Canyon is a fascinating place for weather because there's all kinds of interesting things going on, for sure. If you're going to talk about the history of the Grand Canyon, you got to mention John Wesley Powell. Who was this dude? Well, the famous recreational lake, Lake Powell, was named after him, so you know he must have done some significant things, right? And he sure did. He lived around late 1800s, did a lot of great things. He did some great things for scientific and cultural institutions. He was a geology professor at a university in Illinois, and he was also a U.S. Army soldier. He fought for the Union during the Civil War, and unfortunately, he actually lost his right arm in battle. And so he spent most of his adult life without a right arm. After the Civil War, he became a geology professor, and he declined a permanent position because he wanted to explore the American West. In 1869, he set out on his major journey that he was famous for. This was pretty dang wild. This was dangerous. So what he did is he took 9 other men and 4 boats, and they went through the Grand Canyon on raft. Now, nobody had actually been through there before. So imagine that. You know, it's an unexplored area. You're going down a river that's got some intense rapids. You know that. You don't know what you're going to encounter. You don't know if there are any waterfalls that you're going to have to worry about. You know, they were like, well, nobody's been down there. We got to see what's down there. And so May 24th, 1869, they set out from Green River, Wyoming. They rode down the Green River down through Utah, and that was pretty dangerous too, but they got through there, and they met up with the confluence with the Colorado River, and eventually they got into the Grand Canyon. Yeah, just think about that. Like, you don't know what's ahead of you. So oftentimes they'd have to get out, walk ahead if they could, see what's in front of them, how dangerous these rapids are. Are there any waterfalls? There were some intense rapids they had to deal with. I mean, they had close encounters. They lost boats. They lost food. You could imagine how scary and risky this was. And remember, John Wesley Powell only had one arm. Now, at some point, 3 of these guys said, forget it. This is too dangerous. We got to get out of here. Now, the ironic thing is, they thought they were leaving because it was dangerous and this was more safe to just ditch him. Well, it was only 2 days before the rest of the group actually got out safely that these 3 guys ditched the group. What happened to these 3 guys? They got killed. I mean, it was kind of funny in hindsight, right? You have to at least laugh about it now. People aren't really sure how they got killed, but the general consensus is that they probably got killed by a Native American tribe who thought these 3 guys were up to no good. But yeah, what a journey, what an adventure. But John Wesley Powell definitely deserves credit for making it through. And there was a movie actually made about this called 10 Who Dared. It was a Disney movie made in 1960, so I'd recommend checking that out. How and when did the Grand Canyon become a national park? It started when President Theodore Roosevelt showed up in 1903. He was an avid outdoorsman, loved the place. He was like, this place needs to be preserved. So he actually created a game preserve there. And it wasn't full environmental conservation. It was mostly for hunting, but at least it was some conservation. A little bit later, Roosevelt and another conservation group got together and said, hey, we need to do something about preserving some cool places. And they created the U.S. National Parks Association. In 1906, the Antiquities Act was signed, which allowed for the development of U.S. national monuments. So he went ahead and made that the Grand Canyon National Monument in 1908. Some groups were fighting it from becoming a national park for 11 years. People that wanted the natural resources around there, but that didn't work out. In 1919, it became the 17th U.S. National Park and was signed into law by President Woodrow Wilson on February 26, 1919. So there you go. That's how the Grand Canyon National Park became officially preserved.